So a computer science professor has 7 different programming books on the bookshelf. 3 of the books deal with C++ and the other 4 with Java. In how many ways can the professor arrange these books on the shelves? A, if there are no restrictions. B, if the languages should alternate. C, if all the C++ books must be next to each other. Or D, if all the C++ books must be next to each other and all the Java books must be next to each other. Okay, so let's do it here. For part A is just that there's no restrictions. What's that going to be? How many ways could I stick them on the shelf? Yeah, good. 7 factorial. Nice and easy. I won't even try to write out the details. Again, you'd want to write out at least a sentence to explain where that came from. Part B, what if the languages should alternate? So you're going to have, so first off, you can't have C++ first, I don't think. C++, Java, C++, Java, C++, Java, Java, right? I've got an extra Java. So C++ can't come first if I'm going to alternate it. Java has to come first, okay? So I put down a Java book. How many options do I have for that? Well, there are 4 Java books available. So when I put down my first Java book, there are 4 options there. Then I put down a C++ book beside it. Well, there are 3 options there. Then I put down another Java book. I now have another 3 options, 3 Java books that are left. Then I put down another C++ book. There are 2 of those left. Then I put down another Java book. There are 2 of those left. Then I put down another C++ book. There's 1 of those left. Then I put down the last Java book. There's 1 of those left.
Hey everybody, let's take a break from the example for a sec. The example I'm doing here is really just a single example, and there are literally infinitely more problems you can run into on a discrete math exam. And odds are good you'll run into problems you've never seen before and be expected to apply what you know to solving them. But if you don't understand the content, you have no hope. So if you're taking a university, if you're a student taking a university discrete math course, and you're serious about not just getting a good grade, of course, yes, getting a good grade, but if you're serious about understanding the content, then go ahead and click the first link in the description down below and book a free call with me. Now, back to the example.
Okay, and so what's the answer? We got 4, 3, 2, 1, and we got 3, 2, 1. So we got 4 factorial times 3 factorial. Really what you're doing there is you're saying, take the Java books, permute them in any way you want. Take the C++ books, permute them in any way you want. And then in that order you've chosen, take the first C++ book, stick it between the first and second Java books. Take the second C++ book and stick it between the next 2 Java books, and so on, right? That's what it comes down to. So the order that matters is only the order in which the Java books are in and the order in which the C++ books are in. Okay. Again, you'd want to write a sentence explaining at least something there. Part C, all the C++ books must be next to each other. Okay. So the question is then, if here's the shelf, I've got this chunk of 3 C++ books in the middle, and then I may or may not have some Java books here, and I may or may not have some Java books here.
Hey guys, if you are looking for help with learning discrete math or proofs, I know they're tough, then make sure to subscribe, as I'm literally going to be posting every example I have here for free on YouTube to help you learn and understand discrete math proofs. Back to the example.
Okay, so first thing I want to do, let's deal with the C++ books in the middle. Those can be permuted in any of 3 factorial ways, right? I can choose a first one, then a second one, and a third one. So there's 3 factorial ways to arrange the C++ books in the middle. Okay. Then the question becomes, how many books are on each side? There could be 0 books over here, in which case there could be 0 books over here, in which case there are 4 over here. There could be 1 book over here, in which case there are 3 over here, and so on, right? And so the question, so yes, I mean, I can do just 4 factorial for the Java books. That would go left to right, But then the question is, where does the C++ books go? And so that's probably what I would do, is I would put 4 factorial to sort the Java books in any way I want. And so what I get there is Java, 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 Java. And what I've got is I've got to choose somewhere to put the C++ books. It can either go here, or here, or here, or here, or here. Right? So what I've got there is 1, 2, 3, 4, 5 choices to put it. And so what's the answer? Well, 5 times 4 factorial times 3 factorial. Okay, now really what it comes down to is what you're doing is you're doing 5 factorial, because you've got the 4 Java books, which are all different, and you've got the C++ block. So I just view that block of 3 books as one thing, and that one thing plus these 4 Java books need to be ordered. So there's 5 factorial ways to do that. And once I've chosen where the C++ block is going to be, there are another 3 factorial ways to arrange the C++ books. So 5 factorial times 3 factorial. Okay. And lastly, we're just about out of time here. Part D, if all the C++ books must be next to each other and all the Java books must be next to each other. Well, follow the example we just did. Create the C++ block of books. Create the Java block of books. Put them all the 4 books together. There are 3 factorial ways to create the C++ books, and there are 4 factorial ways to create the Java block of books. Then now all I have is 2 things, a C++ block and a Java block, and I can permute those 2 things. So 2 factorial. Oh, and one more thing to add to my rant from earlier about doing the problems in the book. Don't try to start on number 20. Okay, that's another common issue people have. They see, oh yeah, questions 20 to 30 to 40, these are the ones that are good testable difficulty. So I'll just start there. Problem is questions 1 to 10 and 1 to 20 are there to get you to build up to those. You're going to be completely confused on the higher ones if you can't do the easier ones. If you don't do the easier ones, okay? So take the time, go through all the exercises. Really valuable, really important.
Hey, thanks for watching. Remember, what I've explained here is just a tiny, tiny example in the literally infinite space of problems there could be that you'd run into. So, if you're interested in really understanding this content, getting a good grade because you understand the content, go ahead and click the first link down below and book a free call with me, and let's talk about if I can actually help you do well in this course.